हेलो बच्चों, वेलकम टू स्कूल ऑफ फिजिक्स। आ गए हम एक नए प्रॉब्लम के साथ एंड दिस टाइम इट इज एन इनक्रेडिबल प्रॉब्लम फ्रॉम IPHO 2012 and it is also given in CARTA handouts, in the kinematic handouts. So we are presented for this question four different solutions of an incredible IPHO problem. So I would urge everyone to first of all solve this problem by themselves and then proceed to the video for the exact solutions, which are four different solutions. So चलिए सबसे पहले इस क्वेश्चन को रीड करते हैं. This is question number 49 from Carda handouts. A ball is thrown with an initial speed v naught, moves in a homogeneous gravitational field of strength g, neglect the air drag. The throwing point can be freely selected on the ground. Level z is equal to 0, that is z coordinate इसे माना गया and x coordinate right में. And the launching angle can be adjusted as needed. The aim is to hit the topmost point, that is the topmost point of the spherical building, of radius r, with the smallest possible initial speed v naught. Prior hitting the target, bouncing of the loop is not allowed. Sketch the qualitative shape of the optimal trajectory of the ball. What is the minimum launching speed v min required for the topmost point of the required to hit the topmost point of the spherical building of radius r? So this question is asking कि हमें क्या v naught, that should be the minimal velocity to hit the topmost point of this spherical building in the optimal trajectory. So हमें इस ट्रैजेक्टरी का शेप क्वालिटेटिवली दैट इज अप्रोक्सीमेट करके हम लोग को स्केच करना है एंड यू हैव टू फाइंड दिस वी मिन. सो प्लीज ट्राई दिस प्रॉब्लम योरसेल्फ because it is a very beautiful problem. And now let's proceed with the solution. So this problem is solved in four different methods. The name are, first of all, maintaining safety with the safety parabola. So the first method is the safety parabola method. Second is the algebraic solving, which is just basic algebra and solving a biquadratic equation. Third is a but a tricky way. So we will check it out what it is. And the fourth, which is the brute force method, which I have called the brute force method, brute force. So definitely watch it out at 1.5x for a better experience, and please do refer to the timestamps for efficiently covering the video. And I expect that this video would get a little bit lengthy because इसमें we will cover many different topics of kinematics which are not generally discussed, but here we are going to discuss it and address it for this problem. So चलिए, let us proceed. First method. Please ignore the quality of the photo. I don't know what happened. The quality of photo is dumb. Yes, let us proceed. Method 1, the safety parabola. A safety parabola is a paraboloidal region, that is 3D, that envelopes all the possible projectiles. The curve is a tangent to all the possible projectiles. Let me show what is a safety parabola. So, मान लीजिए यहाँ पे cannon है. Then all the possible projectiles, the green, black, cyan one, and all these black projectiles are the possible projectiles that could occur at different initial launching angles but same speed. So this red curve is the safety parabola, which envelopes all the different projectiles that could occur by this cannon. So this is definitely a paraboloidal curve because this question is we are representing it in a 2D frame, but actually if we do it experimentally then it would be 3D. So it is a paraboloidal shape and not a paraboloid. In 2D, of course, it is a paraboloid, but in 3D it is a paraboloidal region. So we know that from this equation of kinematics, which is generally discussed, that y is equal to x tan theta minus gx square by 2u square cos square theta, which represents a parabola, that is y x square plus c, and here x square is in negative, thus the parabola will be downward open. So substituting 1 by cos square theta, that is sec square theta is equal to tan square theta, and rearranging. So on rearranging, we get this equation. Now let us analyze the condition for the discriminant. So मान लीजिए if the discriminant is greater than 0, then the equation would have two values or two curves for hitting the target at x comma y, one rising leg and another descending. So it means that, consider there is a point at x comma y, and we are considering that the coordinate axis is from this point where the cannon is located. So this is that point x comma y. So if d is greater than 0, then obviously this quadratic equation would have two roots, and it would represent that the curve or the two values of this equation are the two ways or the two curves in which we can reach this point x comma y. We don't know where this point is. It may be inside this paraboloidal region or outside. So if it is inside, consider it to be here, then, or consider it to be this point where I have marked it. So it would, where I have marked it. So it would have two values, that is one rising curve which is representing this cyan curve which is rising, which represents this curve. Yes, and the another version is the cyan curve. You can see that these both these curves are intersecting each other at this point where we are expecting the x comma y or the target to be. So it would be the case when d is greater than 0. Now consider if d is equal to 0. Thus the equation would have a single solution, that is a single curve to hit the target, and it would mean that the curve is representing the safety parabola, which is this red curve. And next, that if d is less than 0, then it would have no solution to hit the target, which means that the x comma y or the target would lie beyond this red curve, which is a safety parabola. So we can put d is equal to 0 and solve to get the equation for the safety parabola, which is y is equal to some constant minus k, which is this g by 2 v naught square into x square. So proceeding further, it can also be proven that the cannon, which is from which all the projectiles are fired, would be at the focus of this parabola. This is very important condition for solving this question, and I would not prove this right now because it would increase the length of this video very much. So it is recommended that you try it out yourself, or instead just believe me that this exists. And the hint, if you try it out yourself, is that represent this equation in form of x square is equal to 4p under bracket y minus k. You have to find p and k, and the focus of the parabola would be at 0. Focus would be at 0 comma p plus k. Don't worry, I will mention this in the description so that you don't forget it. So please do try it out yourself. So let us proceed further. So the first solution, we would reverse the question. That is, we are initiating the projectile from top of the sphere and the minimum velocity to hit the ground. So हम लोग क्या कर रहे हैं कि actually the question says that we have to find the minimum speed from ground to hit the topmost point, but we are reversing this process in order to find the speed with which we are hitting this ground. That is, we are projecting the cannonball from the topmost point, hitting it somewhere, and then reaching the ground. And the velocity at the ground is the velocity that we have to find, because we are reversing the process. Initially, what we had to do is to fire the projectile from the ground, hit at some point, and I will explain why hitting at some point is necessary, but just consider that it is necessary for now. Hitting the spherical building at some point and then reaching the topmost point. So we are reversing this process. So let us follow. Yes. For the minimum velocity, the cannon must touch the sphere at one point as well. That is, the sphere should be touching the sphere should be touching. Sorry, the cannonball must be touching the sphere at 2 points. The first is some point on the sphere, and the second is the topmost point. And thus, this cannonball has to gaze upon that point, the point which it is touching. Before touching the topmost point, it has to gaze upon it in order to obtain the minimum velocity for trajectory. So now let us move towards a very important and useful property of parabola. So it is that if we use a parabolic curved mirror, which is this mirror, and then so it would reflect all the light rays that are coming parallel to the principal axis to the focus of the parabola. Hence, according to Fermat's principle. So what is this saying? That if we have a parabolic mirror, parabolic curved mirror, then it would reflect all the light rays coming parallel to the principal axis. It is not necessary that these rays are paraxial. It is just that these rays are coming parallel to the principal axis. So these rays would be reflected to the focus of this parabola. So according to the Fermat's principle, we know that we would consider first of all two rays. First this one, and second of all this one. This one is coming from here, coming from somewhere, and being reflected towards the focus, and this one is directly reflected towards the focus. So consider a vertical line here. We are naming this to be P, Q, the focus F, and the pole A. So PQ plus QF, that is the distance covered by this ray after this particular line or the reference which we are taking. So PQ plus QF should be equal to the distance this ray is traveling after this this line or this frame which we are choosing it. So it should be 2F, that 2FA, first FA here and then second FA returning back. So PQ plus QF should be equal to twice of FA, and this is very important result which is very much required in the upcoming pages. So first, let us consider the spherical building. We would name the topmost point to be T, the point where it is hitting to be P, some point A which is at the same level of the center of the sphere O. So this is the actual trajectory, which is represented by the orange color, this one. It is gazing upon point P and touching Q, and it is dependent upon us that if we reverse the process, we could take as it is being projected from Q and gazing upon P and ending on the ground. Now taking the safety parabola. So the safety parabola would too gaze upon point P and reach some point Q, which would be the end or the terminal ending of the safety parabola. So moving further, as the projectile is occurring from T, since we are using the reversible process method, it should be the focus of this safety parabola. As I have mentioned it earlier, that if it is proven that if the cannon of the trajectory must be at the focus of the safety parabola, so this T should be the focus of the safety parabola. And since TP is considered it to be TP is this and this is PA. Now consider that PA is a light ray which is coming from somewhere parallel to this principal axis, which should be somewhere like this, from Q to O. Then it is reflected by the safety parabola at point P, and we are considering that the safety parabola is a parabolic curved mirror. So it is reflected here, and this P point is also, the parabola is also tangent to the sphere at point P. So this line which I am representing here, Yes, this must be perpendicular. This OP, which is the radius, must be perpendicular to this tangent. And since this OP is normal to the tangent, and TP is being reflected to a vertical, TP is reflected by the parabola at point P into a vertical ray, PA. Angle 1 should be equal to angle 2. Angle 1 should be equal to angle 2, which is by this first law of reflection. And since this is the normal, angle 1 should be equal to angle 2. Now, and next, since this is an isosceles triangle, angle 2 is equal to angle 2, angle P equal to angle P, and since these are parallel rays and this is the transversal, angle 1 should be equal to angle 1. So, and since angle 1 is equal to also angle 2, these all angles PTO, POT and OTP, that is angle T, angle P and angle O, all are equal. Thus, it should be 60 degree and all these, and this forms an equilateral triangle. So we get PT is equal to R since it is an equilateral triangle, and by trigonometry we get PA is equal to R by 2, that is R cos 60. So now using the important property of parabola that we read earlier on this previous page, PT, twice of PT plus TO, which is the distance this light ray would be covering, that would be going along PQ. So twice of QT plus OT must be equal to this light ray, which is being reflected towards the focus. So PA plus PT. Since PT is also R and TO is also R, these would be cancelled and QT would be P by 2. And we know that PA is R by 2. So further proceeding, now we are again reversing the question, which is into the original question, that we are taking the projectile from the ground point and finally reaching to QT, which should be the end of this safety parabola. Because just by altering the safety parabola into the actual trajectory, we would get the same result. So let us just consider this and conserve the total mechanical energy. So initial kinetic energy would be equal to final potential energy, which is 2R, this height 2R plus QT, which is R by 4. So finally we get that V naught must be equal to under root 4.5 GR. Going to the next solution, algebraic solving. So we know that this is the equation of the safety parabola. Now the equation of circle if origin is at T. So this is the diagram. We know that the projectile is being fired from the topmost point as we have reversed this process. So this must be our coordinate axis, as it has been not proved but explained earlier. So this must be the coordinate axis. So the equation of this circle is represented by x square plus y plus r whole square is equal to r square. So it represents that the radius of the circle is at 0, comma minus r, 0, comma minus r. So this O is at 0, comma minus r. I hope this is very much clear. So solving this equation, we obtain a biquadratic equation and putting the D to be equal to 0, that is discriminant to be equal to 0, we get V naught is equal to GR by 2. So what is V naught? V naught is the velocity with which it is being fired. So yes, it is the velocity with which it is to be fired. So by reversing the process, we have to find the velocity with which the cannonball is hitting the ground, that is velocity V. So on conservation of mechanical energy, we get final velocity and considering the ground to be reference frame of potential energy. So V is equal to half mv square is equal to half mv naught square, and the potential energy at this point would be 2 mgr. So on solving it again, we get V is equal to 4.5 GR. So now proceeding towards a tricky solution. So knowing the fact that the initial velocity is perpendicular to the final velocity in a projectile of smallest possible launching speed. Ignore this minimal, sorry, here is here should be the this bracket, not here. So the initial velocity is perpendicular to the final velocity in a projectile of smallest possible or minimal launching speed. So this is applicable in any case of projectile, either it is on it is on an inclined plane or a ground. So just for the proof to be simpler, we are considering it on the ground, but it is also applicable on an inclined plane. So we know that for minimal velocity, the projectile on the ground, the theta should be equal to 45 degree or pi by 4. So for finding the angle between them, we are just dot producting the initial and final velocity. So the initial velocity is vi and final is vf. So vi dot vf, vf could be written as v vector vi plus vector g times t. So on dot producting, we get v1 square, as this should be in both same directions. So v1 dot v1 gets v1 square, and we have to finally solve what is v1 dot g. So yes, so the projection of v1 is v1 cos theta along x-axis and v1 sin theta along y-axis. So v1 sin theta is opposite to the direction of g. Hence, we get v1 sin theta times g and cos 180 degree, which gets minus here. And the time for projectile is 2v1 sin theta by g, as we know, which is time of flight. So solving this and putting the value of theta to be pi by 4, it finally is resolved into v1 square. So v1 square minus v1 square gets 0. Thus, the angle between the initial and final velocity should be 90, as the dot product is 0. So finally proceeding, yes, consider the following markings. Topmost point T, this point which has to gaze is P, and the center is O. Angle TOP is theta. So since v naught, which is initial velocity, and which is the final velocity for this small projectile, for this projectile, it should be perpendicular. These both velocities should be perpendicular to each other. So upon by using basic geometry, we get this. If this is theta, this should be 90 minus theta. So first equation comes from conservation of mechanical energy, that is from this point to this point, and we are considering the reference frame of potential energy to be the horizontal line along t at the height of t. Second equation, v sin theta, that is the v naught sin theta. Sorry, this should be v naught sin theta, which is this component, times t, the time taken to reach from t to p, is equal to r sin theta. So this is along x-axis, equation 2. And equation 3 is along y-axis, that is the distance being traversed. And here should be a minus sign. Don't worry, the answer is correct. Just I forgot this minus sign. So v cos theta is the perpendicular component of the velocity, which is along y-axis. This is the displacement r total to minus this r sin theta, r cos theta, which is equal to v cos theta, the perpendicular component or component of velocity v naught along y-axis, times t minus half gt square. So solving equation 1, 2 and 3, we get v naught is equal to under root gr by 2. So what we get is that the initial velocity to fire this projectile should be this. So since we had reversed the process, we had to find the final velocity to which the ground is being hit, which I had explained earlier. So applying conservation of mechanical energy, we get, and we have assumed that the final velocity with which it hits the ground is v dash. So v dash is again under root 4.5 gr. And the brute force method, or the brute force method, which is very lengthy but still it is useful, that first of all, now we are not using the reversible process, and instead we are projecting the cannonball from the ground to some point P, and then it would gaze upon P and reach to point T. So by using by using the conservation of mechanical energy from point Q, which is the point on ground, to point P. We would get this equation at height r plus r sin r plus r cos theta, r plus r cos theta. Second equation comes from the equation that is y is equal to x tan theta minus gx square by 2 u square by cos theta, which is this equation. So using this equation we get this, and it is not very tough to formulate this out. So after solving this second equation, we would get an equation for v in terms of theta, and since we have to find the minimal velocity, we would differentiate the v with respect to theta, which is the minima. So differentiating it, we would get cos theta should be equal to half 1 by 2, and thus theta is equal to 60, which we had derived in the earlier three processes or earlier three solutions. So finally solving it, putting the value of this theta in the equation derived from in the value of v derived from this equation, and putting it in the conservation of mechanical energy equation, we would again reach to that v naught, that is the initial velocity, to be equal to under root 4.5 gr. So I really hope that you liked this solution very much. It was a very beautiful problem, and being solved in 4 different ways clears out more processes and ways in which we can solve a particular problem. And we will be coming up with much more videos in future. Till then, bye bye, and thank you very much.